This is the 1850 Bear Mill outside of Dayton, Ohio. I'm Darren, and this is the Industrial Revolution. So this mill is not the first on this site. The first mill actually was built just downriver a bit in 1832. That was a corn cracking mill. Now, cracking mills were just with corn, and they were used specifically to break up the hard corn kernels in order to make it more digestible for animals. If you have chickens especially, or if you're feeding it to other livestock, you want to crack your corn. It makes it more efficient feed. Does not, however, make flour, and that's why this mill was built. So it started out in 1848 and took a while to get going. In 1849, Gabriel Bear bought the mill, still unfinished, and finished construction here and started operation. One source says that the original millstones were actually locally produced millstones that were defective. Talking with a miller inside, though, she believes that the millstones that were brought here by Gabriel Bear were actually originally purchased in France, and that no local millstones were ever used here.
Let's follow the path of the grain as it would have traveled through the mill. First, of course, the farmer would bring the grain to the mill. They could carry about a ton of grain in their horse-drawn wagon, typically either in 200-pound barrels, about 90 kilograms, or later in 50-pound bags, about 23 kilograms each. See those doors up there? There's one for each floor. That's the 19th century loading dock. The rope and pulley sticking out at the top, that's their forklift. Let's go upstairs and pick up the story from there.
Grain started out its journey here. It came in through the door here. It's tied on here. These were typically 50-pound bags that were sent up, cloth bags. And once you had it on here to lift it, that rope goes over to here, pull down on this lever, which pulls that bottom wheel into the top wheel. The top wheel, of course, was spinning, and that would hoist the bags. So you could probably lift a couple bags at a time here. The one interesting thing on this floor is this first bin. All of your grain would start here. Grain that was brought in tended to be kind of dirty. So it'd be brought in, put into this chute, and you'd feed down here. So you have this little lever here. This is connected up on top to a trip lever, and that trip lever, as a belt goes around, it lifts this and throws like a little handful or so of grain through each time into this elevator. So here's the other end of that chute. And you see the trip lever here. So when this trips, the belt turns here, lifts this up, lifts that, and that opens that chute down below. So as this belt turns, it trips that and slowly feeds the grain into the elevator, which takes it up into the first cleaner. Different cleaning machines, a very coarse cleaner here. You have the different sizes of holes, depending on what you're cleaning for. And I do have permission to go back through here. Then we go to another cleaner here with much finer holes in it. Now, obviously, if you're doing corn, to give you an idea of scale here, this is too fine for corn, but for wheat or something, wheat, buckwheat, anything like that, this would allow that to work. And then beyond it, you get something with brushes and fan. That takes any like fungus off, and he brushes the dirt off the grains, things like that.
After cleaning, the grain was routed through a complex network of chutes and elevators into one of many bins. From there, the miller could direct the grain into one of 3 stones, or one of the 3 much newer high-tech roller mills that were added between 1873 and 1884. We'll come back to the actual grinding here in a minute, but for now, let's keep following the grain, which has now been ground into flour. Depending on what you're grinding and what your customer wants, you'll usually need a bit more processing. This is called a flour dresser or a flour bolter. This one is only set up with a single sized mesh, but some are split into several screens and several separate bins. Why would you do this? When the flour comes out of the millstone, it may have some different sized particles, some larger, some smaller. When you grind corn, for example, you may want to separate that into corn flour, which is the finest, several different grades of cornmeal, and corn grits, which are the largest. Anything bigger than grits will actually fall out the end. They have several flour dressers connected upstairs here. Likely these were set up with different size screens, depending on what you were grinding and what your customer wanted. From the flour dresser, the flour went to another bin, or potentially several bins if it's sorting, and from there, finally down another chute to be bagged. Of course, you didn't get to keep all the grain that you brought into the mill. You had to pay the miller. Early grist mills typically charged a percentage, maybe 30% of your grain, as their fee for grinding the grain. You come in with a full ton of grain, you leave with about 1,400 pounds or 635 kilograms of flour. One thing I saw here, which I haven't seen before, is this bran packer. Bran, which is the outer layer of the grain, is extremely light and fluffy. It makes dust seem heavy by comparison. Just dumping unpacked bran into a bag doesn't give you so much, so using a bran packer would actually let you put a lot more bran into a single barrel or bag. You can't pack down flour, but with bran, you might actually be able to double the amount you can fit into a bag. Before we head down to the millstones, there's one more thing I want to show up here. Bear's Mill has to be the most intact 19th century mill that I've ever visited.
So a lot of historic mills have pulled all these elevators and chutes out, or pulled most of them out over the years. Now certainly when mills were in operation, they changed them around, they reconfigured things, so they also removed some. But most mills you can go into today don't have anything like this. You know, you have 1, 2, 3, 4, 5, 6, 7, you've got, what, about 10 in a row here. You've got about the same down here. In the next row, you've got like 20 elevators and chutes here, and you see up in the ceiling, there's still more that have actually been removed. You know, these old mills, they were pretty complex factories, really. They had to move different kinds of grain around to get it to where you wanted to go, get it to where you needed to go.
Like many other mills, eventually Bear's Mill was fitted with its own belt-powered electrical generator hooked up to the larger of the 2 turbines. This one produces 125 volts of DC power. Since it produced DC and not AC power, it was likely installed before 1896, and certainly before 1897, when the company that made it was purchased and the name changed. By today's standards, it doesn't produce all that much power, but with a pair of 30 amp outputs, it provided plenty of power for all the mill's electrical needs. Now let's head back downstairs to check out the milling process. So let's get to grinding some grain. Originally, of course, when grinding tons of grain every day, the grain would have come down these chutes to the millstones. Today, they do small batches with 25-pound bags, so they just pour it directly into the hopper. See that big steel wheel in the background? That controls the larger of the turbines below us. It actually broke the day I was there, and it just spun without actually doing anything. Stick around and we'll talk more about it, and even get to see some pretty special stuff that's usually underwater. That wheel she's spinning is to raise the runner, or a top millstone, to help get the stones going. The steel wheel opens the wicket gates on the smaller of the two turbines. That turbine runs all three stones and the one flower dresser just to the left. Everything else in the mill is run from the larger turbine. The gearing up above, that runs the small elevator and flower dresser to the left. They don't actually use the flower dressers, but just hand sift as needed. The stone weighs about 1,000 pounds or so, but the wheel connects through multiple levers, so you can make very tiny adjustments with fairly easy turns of the wheel.
Right. Something that doesn't show up on the video, the whole floor is vibrating.
Yeah. Yeah. Much better now. So when she makes a fist,
It definitely looks
ball, and it kind of
much finer flour.
A little bit of a form, yeah. So if you want to go ahead and change the bag, so we have to get the stones going without grain in between, and then they start touching each other, then they spark and make that burning smell.
Right.
And then we feed the grain in, which we have the RPMs on our stones, on our line shaft there. Yeah. So I tell people during tours that the miller uses all five senses for the grinding process. I'm looking at that. I'm making sure it's spinning fast enough. I'm listening to the grain. I'm making sure that that's a nice steady flow. If it stops, then we get that burning smell. You know? And my nose, making sure that burning smell doesn't come back after that initial process. And then the feeling of the flour when it comes out, so we know the right texture. And then tasting it, obviously. We gotta make cookies later. So.
Yeah.
The problem I hadn't thought about is what happens during a drought.
A drought, and we don't have a lot of water in our millrace. The water will continue to drop as we grind. It'll get harder and harder to keep up that momentum. So sometimes we do have to grind a little coarser, and then we'll just have to sift out some stuff later on.
Right.
So it's just an extra step.
And of course, the miller always has to keep an eye on everything and keep the hopper full.
So the way the wheat lines up going down into there.
When milling, you have to constantly make small adjustments to the feed rate, the stone spacing.
This just raises and lowers that.
Yep.
But our little funnel here sometimes will hit the stones and make that sound.
They have three sets of stones here. Today, they only run the one on the left, but at full production, they generally run two at a time, with the third one having maintenance done.
And this one over here has been disconnected, but it does have the crane on it still. And the crane you can move from wheel to wheel.
Once lifted, you can flip the runner stone over and get to both stones to redress them.
This one has a cement cap on it, I see.
It's got like a plaster,
plaster.
to keep moisture out.
Okay.
And then like little lead weights to level it off.
Yep.
Yep.
Yep. A lot of wheels had weights just because they have to be balanced. If they're not balanced, they wobble, it grinds unevenly, destroys your stones pretty quick.
Yeah.
Sometimes you'll even have pockets in the stones. And the banding to help hold it together. Were these single solid stones or were these?
They're pieced together.
Oh,
They
yeah.
are French burr stones.
Yep, you can see here
Yeah.
where this is pieced together.
In a busy mill, running all day long, you actually need to redress the stones fairly
often.
often if you want to keep producing top quality flour.
So what we have in there now is soft wheat. And what I'm going to pour in next is einkorn.
Okay.
I don't know if you've heard of einkorn before. It's ancient grain.
Okay.
A lot more protein and nutrition. So I just kind of feed the rest of the soft wheat through, and then I dump in einkorn. And it takes a little bit to switch over down here,
Right.
and then I gotta set it down here, put it down. Still some soft wheat, but I can see some einkorn. It's got more of a yellow. So I'm gonna go downstairs and tell Pam to switch over
Switch the
to
bags.
einkorn.
I didn't notice this when I was here, but while editing, when I was fast forwarding through this clip, I saw this. Check out the dust coming off the stone. As soon as the milling started, you'd smell this everywhere in the mill. You probably noticed everyone's wearing coats. While there's no heat up here in the milling area, the dust is extremely flammable and can even be explosive, so mills historically were unheated and operated only during daylight hours. Still, that didn't actually stop a lot of them from burning down. Milling's done for the day.
Turn the water power off, and then I'm going to lower the stone back down.
They grind grain here year-round, but not every day, and typically only for an hour or two.
Why do you lower the stone when you're done?
Because it would want to keep moving. There's
Okay.
just enough water getting in there
Oh, just
through the turbine,
okay.
and it has that momentum, and the 1,000 pounds moving, it would want to keep moving.
Okay.
So we try to keep the grain flowing into the stones as we lower it, because the grain also helps stop it.
Right.
They asked me to tell you that if you'd like to visit and see the mill in operation, please just give them a call in advance to let them know when you'll be coming so they can be sure that it's up and running when you get here. They grind quite a few different grains and sell all the flour they grind here. So if you'd also like to pick up some of the absolute freshest flour you can possibly get,
That's the basic day in the life of a miller, except you do it for 10 hours.
Yeah.
these are the steel rollers for the roller mills. This newfangled technology wasn't invented until the 1860s.
Here are the roller mills. These aren't in use anymore.
They're no longer in use here today, but with everything still connected, it really gives you a good idea of just how complex all the chutes and elevators can actually get inside of a mill.
So this hopper is weird. You have the hopper that feeds the mill with two side ones. That one goes to a bagging station. Not sure where that one goes.
On the elevator to go up the next elevator.
That one goes up to,
It's
okay.
going down, and then the back
Right.
side of this elevator would bring it back up,
That goes back up.
and then dump it in here.
So you'd go through the series of
Yeah.
mills.
So it can.
Yeah.
Or they can pull it off that first one.
Right, so this one can go straight from the hopper into here
Yeah.
and get bagged.
There's a lot of places that I think are like test chutes. They're testing.
Okay.
If they were to, I'm guessing, if they were to open this chute, because there's nothing happening before it goes in here. So
Right.
I think they're just testing what kind of grain they got in there. because it
Well, is it cleaned? It's cleaned up there
Yeah.
before it hits
it
this
is
point.
clean, but they may not know. I don't know. Maybe they don't remember what they put in that hopper or that bin or whatever. So they're testing it
Okay.
in that bag to see what they have, and then okay, we're running this through, and that's my guess. Because there's several places like that where I'm like, what's that doing? Like it doesn't.
Right. It just doesn't seem.
There's one right before the first cleaning machine too.
Uh-huh.
Like, it has to be just them. Okay, what did we dump in that bin yesterday? You know what I mean? Like,
Or to empty it.
or to empty it, yeah, and get it cleaned out before the next product. Yeah.
Plus the barrel weight.
Remember that wheel I mentioned that didn't work?
Okay, so, our
That wheel
turbine
connects
is
via
sitting
shaft
over
to the
here.
larger of the two
I'm
turbines
gonna
down
turn it
below.
on in the on position, and Pam is gonna raise the top.
And that
off
turbine
the
operates
bottom
all of the other
because they
equipment
weigh
here in the
1,000
mill,
pounds, they're
except
that
for
heavy, they don't wanna
the
lift
millstones
it.
themselves.
So we have to raise it up, and then turn this
The miller
on.
tried to turn that on when I first showed up to let me see everything in the mill running, and unfortunately it doesn't work. So the turbines normally sit under 9 feet of water, which is great. It lets them operate all winter long, but it does make it a little bit hard to work on normally. When they finished milling the grain for the day, it was time to figure out what was actually broken. To do that, we have to be able to actually see the problem, and that means we get to see something very few people ever actually get to see. We actually get to drain the Millrace. Gabriel Bear dammed up Greenville Creek here to create a mill
That'll be
pond.
all gone next
The
time.
original
Here,
dam
we
was
just
made
did
of
a
wood,
repair.
but in
We were
1926,
having
that
water
wooden
leaking
dam was
from
replaced
the
with a concrete
Millrace
dam.
side back to the creek side.
Millrace, which is on the left
So
here,
we,
is the generic
laid
term
a
for the water supply for a
geo-web
mill.
down and
Uh-huh.
put some
It might be an
local
open
block
canal like this
down.
one,
Never
or
heard
it
of
could be an
those things.
elevated wood
I
or
know about the
stone
geo-web.
sluice.
That's
Okay.
they use that on
It
mountain bike
connects from a
trails.
higher point,
Okay,
which
yeah.
might just
The
be
aqua
upriver
block is
or
like
in a mill
It
pond.
looks like
So it used to be that they had to turn a crank by hand a lot to raise and lower the gate into the mill race. But a while ago they did an upgrade to the system, and now they can just use this battery-powered drill. You can see the gate very, very slowly lowering, which is slowly closing the gate between the mill pond and the mill race. Of course, now you have a full mill race with no outlet, so we have to go back inside to open the lower gate.
Okay, here's how we raise the gate underneath the mill so we can drain the mill race.
At the dam, there was a gearing system, and you could open and close it with a simple rechargeable drill.
We have this pulley system on here, that way it doesn't drop when I switch
Right.
handle the wrench.
Well, that's new, and here in the mill we don't have that. It's all brute force.
Real high tech here.
Yep. Brute force. But this is lowering. This is raising the gate down below to drain the mill race so we can get to the turbine to find out why the turbine's not working. And the big red wheel, that's a tensioner on the belt system, or
Yeah.
it's for the main belt off the larger turbine.
And that's the one we're having problems with.
The big lever opens up the gate, and the rope on the pulley system, well, that's used to hold it in place while you're resetting the lever. Now that it's open, we wait, but surprisingly not very long. Let's go outside and take a look at the progress. This is the tail race when I first arrived. The tail race is the channel that the water takes after leaving the mill as it heads back down to its river. The mill's not running here, so this water is just leakage to the turbines and around the gate. These gates were never built to fully stop the water, and obviously they don't. And here's the tail race with the lower gate open. We do have to drain that entire Millrace down about 9 feet though, but that's a lot of water. Let's walk around to the other side of the mill and take a look at the Millrace. It's not taking very long, and you see the water level's already dropping. The wooden strainer here was called a trash rack, and you can see how it got that name. You'd always have fallen branches and other debris falling into and drifting down a Millrace. The really tiny bits, like dead leaves for example, those could go right through the turbine without causing any problems. But some of this bigger stuff could jam up or damage things. That's what we thought might be the problem here. Surprisingly, it only takes about 20 or 30 minutes to fully drain the Millrace to the point where the turbines are accessible. With the water dropped, the miller went down to the turbines and was quickly able to spot the problem. It's around on the back side, so we can't see it, but there's a broken tooth on this mechanism, which opens and closes the small wicket gates, which go all the way around the turbine and let the water in. Since this larger turbine runs everything in the mill, other than the millstones, I'll be making another visit back to Bear's Mill to see this part in operation.
So Bear's Mill here stayed pretty much in full operation from 1848 until 1979. And in 1979, the owner went into kind of partial retirement, gradually started cutting down production, but also did something else. Gradually started converting it more as a tourist attraction. Added the store that's inside, a little bit more of a museum setup inside, and tried to attract people to the mill. In 2000, the Friends of Bear's Mill was created and took over the mill at that point. And that lasted until 2020, when the Darke County Parks Association acquired the mill. And Darke County Parks currently operates it. So it's in almost continuous operation, just more or less, from 1850, except in 1862 to 1865. And during that time, they actually did in fact stop operation here at the mill. It was during the US Civil War. And there was a lot of concern that if this was an operating mill, that raiders from the Confederacy would come up here and burn the mill. That's something that was unfortunately common, and they obviously didn't want that to happen, so they did shut down for a few years then. Other than that, this has remained operating. It remains operating today, grinding multiple kinds of grain on a regular basis. Operates year-round, which for this part of the country is pretty unusual, especially for a water-powered mill. And is a great representation of 19th century milling technology and a part of the Industrial Revolution.
Hey, wait just a second before you go. I need your help to keep the channel growing here. First thing you can do is really easy. Just like, subscribe, share this video. Tell all your friends about it. That spreads the word. YouTube will see that and we'll show this to more people. Commenting more than just 2 or 3 words. YouTube says that's the most important thing you can get. It's the best kind of user interaction there is. So you can comment more than just 2 or 3 words. Also, if you're able to and are interested in helping out financially, these are pretty expensive videos to film, a lot of travel costs on top of the hours of work I do here. You can help out at patreon.com/industrialrevolution, or become a member here on YouTube, or a single contribution through Super Thanks. Also have an affiliate store. If you click that, anything you buy there, a percentage of that purchase will come to help fund the channel. Thanks for your help, and look forward to seeing you next week.